After we have already started to solve maximum and minimum problems in the last lesson with the help of Quest chapter 13F, I now ask you to have a look at chapter 18E in our Cambridge textbook. Please read through the examples 8 to 11 either now or after the video, because they show some very nice problems with relation to this topic. What I want to emphasize here is what happens if a maximum or a minimum is at an endpoint. So this only is for functions which are defined on an interval. To identify a stationary point, we do the same procedure as always. We find the first derivative and say it's 0, and then find the stationary points and determine if the stationary point is a maximum or minimum. However, it may happen that the endpoint of an interval turns out to be an absolute maximum or an absolute minimum. Corresponding points on the graph of that function are not necessarily the stationary points. So therefore, we can now recommend that we follow the following steps to solve maximum and minimum problems. So first, when you have a problem, I'd recommend to draw a diagram. Illustrate the problem where possible, label it and find the values for the variable. Second step, write an expression for the quantity that is going to be maximized or minimized, means write an equation for this quantity and write it in terms of a single independent variable. Once that's done, you can find the first derivative of that function and say it's 0. Solve the equation and you're going to find the stationary points. Once we've done that, we need to determine whether those points are local minimum or local maximum or neither. Could also be a point of inflection. So then, when we have a function which is defined on an interval, we need to make sure that the values at the endpoints of those intervals, or we need to check if those values are a maximum or minimum as well.